stuck around, thank you so much. We're going to transition to what we're calling Industry Day. If you're wanting to have sidebar conversations, just ask that you step out. If you're hearing this, clap your hands. Thank you. If you want to have sidebar conversations, completely fine. Just step outside. We're going to have this Industry Day. We want to work quickly. We're a little behind schedule and get these folks. So two things. One, project calls take time, 90 to 6 months before they get released. We're working on them with our government team. 6 or 7 months. So for this effort, John Martin will speak and introduce himself, Evan Handler and Kyle Cobb. So I've asked some of our government folks as well to give an update and overview for each of these. Order of operations for this, it's going to go Delta Qual, or it's going to go introductions of these three folks, Delta Qual questions, hard line in the sand. Next project call, GOTHAAM questions, hard line in the sand, and adjourn. So yeah, this is an opportunity for you to ask questions. We're going to write them down if we don't have answers. Q&A for these calls are due a week from today, April 21st. So if you have questions, if outside of this meeting, you have to submit them by next Tuesday. And then we will respond by the end of the month, a week from that, end of the month, with answers. So John, go ahead first.
Thanks, Ben. So my name's John Martin. I'm the AM Research Director at America Makes. Been with the Institute for about 3 years. Prior to that, I worked in industry and was a professor at Youngstown State University in Youngstown. So as far as my role at the Institute, it's obviously more on the technical side, but for this specifically, these project calls, I was the lead on the America Make side to help draft the RFPs. I'll give most of the credit as far as all the, the technical content and the breadth of each project call to these two gentlemen if they want to speak on that briefly, but really putting together a lot of insights from the SMEs within the DoD, and then on our side, just trying to communicate it out to membership as effectively as we can. So I'll hand it over to Evan.
Good afternoon, everybody. Evan Handler. I am with the U.S. Navy based out of Naval Surface Warfare Center Carderock Division. I am detailed as the Government Chief Technology Advisor for America Makes, supporting OSD ManTech and obviously Robin and the rest of our government PM team out of the Air Force to help facilitate the Institute from the government side. In my role, I am responsible for overseeing and helping to direct the technical portfolio for America Makes. So trying to get involved, help shape what some of the project calls are looking like, shaping what some of the other R&D efforts are, trying to help direct them as needed. Trying to keep an eye on the projects, but then obviously I can't do everything. So very much enjoy this one, because I get to see all of the good work that we're doing when I can't pay as much attention to some of those I'd like.
All right. Good afternoon, everyone. My name is Kyle Cobb. I'm the Deputy Chair for the Joint Additive Manufacturing Working Group that is led of OSW R&E's Manufacturing Technology Office. My role in that is to convene over 300 members across the military services and defense agencies in order to operationalize additive manufacturing. I'm joined today by my fellow co-facilitators, Ms. Elisa Peters and Ms. Sarah Topper. Ms. Kate DeLille is currently not here, but hopefully online. For the purposes of these calls, I am the resource sponsor. So when we get to those questions, I'll do my best to answer those or point you to the direction of the SMEs. Thank you.
All right, so first project call is called Delta Qual 2.0 that I'm going to go over, and then after that one, we're going to go and take questions on it. And then after that, we're going to go over, I'll read it now and refer to it as GOTHAAM after, but generation of technical data for high strength aluminum alloy material, otherwise known as GOTHAAM. So for Delta Qual 2.0, these slides are abbreviated. We do have a more detailed set of slides that are online, and then also the RFP. I would highly encourage you all, obviously, to refer to the RFP, but there's a lot of good, I think, technical context in there as well. So as far as Delta Qual 2.0, there's 3 topics. Topic 1 is titled Quantitative Measurement-Based Installation Qualification. It's focused on getting a better understanding of the subsystems within a laser powder bed fusion system. And this is to provide enhanced installation qualification, but also to take that information and incorporate it into basically, the lifetime ownership and operation of the equipment, to understand things like requalification, when is it needed, and if so, to what degree. Basically, where are you operating at as far as within a healthy, if you want to call it process window or operating window, your process drift, what's acceptable, what's not, really understanding those on a much more fundamental level, which has been something that's been brought up for quite a while. And so we're really excited about this project call as an institute. We've been hearing this from membership for a long time. It's just one of those things it's not maybe it's not glossy as far as like new and innovative. It's more kind of taking a step back and saying, okay, do we understand the fundamental things as well as maybe we think we do? So looking at things like laser for sure, gas flow, multi-laser alignment, build plate. So there's been a lot of studies on these, and even some that's been done in the Institute to basically identify that, yeah, these maybe aren't as repeatable as we always think, but to really understand that more in a production environment. What does that look like when you're in a production environment? And okay, so there's some process variability in some of the subsystems, but that still doesn't tell us what is okay and what isn't okay. Just because you see some variability doesn't necessarily mean it's detrimental to the parts coming out of the printer, but it also could. And then some of the effects as they combine. So looking at things like that, there's going to be a red team. That's topic 3. I'll go over that in a minute, but that's similar to the theme of other red teams that we've had, and similar to the one we had on Delta Qual 1.0, where they're kind of overseeing the project in a way, I guess. But I'll get into more of that on a couple other slides. And then also on topic 1, we're going to have training material developed in coordination with America Makes EWD team. So this is kind of a different flavor. We've probably had this before, but this is a little more deliberate as far as what we want to get out of it and some of the deliverables. So it's a EWD kind of element wrapped inside of topic 1, and a lot of it, or I'll say a special focus, especially on the EWD side. The EWD director has really been trying to push laser optics training. And that's one of the subsystems that are going to be studied, but also understand that better, and how to train operators on how to recalibrate it when it's needed and necessary, and how that can affect your print quality. So just couple things I'll mention. There's a lot more detail in the RFP, but as far as a little bit high level on the technical side, 3 laser powder bed machines are required, a minimum of. So 2 matching systems are very similar, in other words, and then 1 different. So the ones that are very similar, and this is basically like to have a layer of control for your experiments, to try and get down to the different layers of variability that you might be having. So you have 2 similar laser powder bed fusion machines, and then you would do a change of either some sort of subsystem component on there or a software replacement. But really the idea is to kind of do like a swap out. How does that affect those? So you have the one printer unchanged, the other one changed. And then what kind of change do you get? Do you get minimal change? Do you get some change? Or do you get a lot of change? And then quantifying that change as far as, is it acceptable or not? Do I need to do requalification? And if so, to what extent? What kind of basically reinvestment am I looking at in doing this? So trying to basically replicate what would happen in a production environment after you're running these printers for a while. And then also, so you have those 2 printers paired up, and then you have a different printer for a third party to compare that to the other 2 that are similar, to get differences there. And then another aspect to keep in mind is, well, I just mentioned that. I don't know, there's a bunch of extra stuff in the RFP, but one thing I did want to mention was materials. So no Tie 6.4, no ALC 10 mag. And that's just because this project inherently is going to be producing a lot of material data, which we've already produced a lot of material data on Type 64, on Delta Qual 1.0, and a lot of our other projects. LC10 Mag, as we all know, has been out there. They're fine. There's nothing wrong with those materials, obviously. But we want to look at, further developing material data sets for other materials. But we're not looking for a novel material. This has to be very mature, already shown on an existing commercially available laser powder bed fusion platform. So I'm not going to name anything. There's no like secret one. If you guess it, you win. But it does need to be relevant to the DoD. So topic 2, this one's bracketed qualifications. Another one, fantastic. Right. So this is where you have basically a qualification window or a bracketed qualification acceptable range for your process parameters, and really understanding that. And not only so looking at things like laser power scan speed, but also some secondary controls that you could track as well. But really it's to get a fundamental understanding of what is an acceptable process window, not just to define it and say, here it is, but to use it as an operating condition. And then to understand where the bounds are at. So not just understanding where that envelope is, but really, I wouldn't say more so, but equally so, understanding where the bounds of that envelope are at. So when you're approaching it, when you're at it, and when you're beyond it. So there's going to be study involved of basically what that, if you want to call it that cliff or that getting into that unacceptable region, what does that look like? And being very, very familiar with that to understand when your process drift, or however you want to, look at it, when your process is, you're running, say, for 6 months or 8 months or whatever, it gives you a pretty good indicator of, okay, we need to look at this and do a requal or a semi-requal or whatever, something, an investigation, instead of just saying we're going to do it every 6 months or we're going to do it every year or whatever, and that seems to work. So to basically decrease cost, increase efficiency, and just be smarter about it, is the idea. So there's going to be test plans involved to study all this, coupons. We don't want to make it a study of printing a bunch of coupons and getting, some sort of material data set, but it does need to be validated with material data set, but it's not like we're asking for a CD basis or anything like that. So that's all going to have to be balanced. It depends on how many machines you're going to do and what the breadth of the study is. We're leaving that open to the proposers, but the main idea is taking these lessons learned and having people that are in a production environment be able to leverage them and give them much more direction. And also mention too, well, maybe I'm getting ahead of myself, but on the red team, they're going to coordinate with topics, the teams on 1 and 2, to help look at potential new standards to incorporate for qualification procedures and process procedures to help basically part manufacturers and how they could do things a little better and more cost effectively. In situ monitoring, it's encouraged. You could use it, but it's not to be like some sort of fundamental source of truth, like this is what we based our decision off of, or our processing window. We do not want that. You can use it to supplement the study, but we want the information, the ground truth for the bracketed qualification to be really, really justifiable and defensible, not, we developed it with newer technology that isn't vetted itself. So I mentioned the validation and the test matrix. So there will be a lot of, testing and coupon testing to validate this, obviously, and then a study of risk and cost. So risk associated with this new approach, we want to understand that as well. Topic 3, red team. So the red team is going to help advise and guide the project leads for topic 1 and 2, and also harmonize the existing standards, help guide SDOs on improving existing standards, drafting potentially, not creating standards, but creating drafts that could lead potentially to new standards, working with SDOs on that front. The KPPs, so it's not like we're looking into getting any kind of crazy scope creep, but the KPPs will likely probably evolve in tandem with the red team. And the red team is also going to be working with a government advisory team. This is to make sure everything is going to be aligned with what industry needs and DoD needs at the end of this. So, you know, these projects go on for a few years, that it didn't somehow go down a road that is not in alignment with what the qualification needs are going to be from some of the platform owners in the DoD or some of the primes, people that are going to need to sign off on this and have agreement with it or buy in. Lessons learned is another thing. And then the training materials. So they're going to be developing the training materials that were mentioned in topic one. Red team's going to be the one coordinating with topic one team, developing the training materials, and then implementing those in coordination with America Makes EWD team. And then here's the breakdown for the topic numbers and the funding profile. So topic one is going to be 2 awards, 2.7 million. Topic 2 is going to be 1 award, 2.7 million. And then topic 3 is 1 award, 9 million.
Okay.
Oh, I'm sorry. Yeah, thank you for that. Yeah, the red team, if you get the red team, you get $9 million. No, yeah, 900,000. Yeah, I have a lot of proposals for that one. So yeah, and so the cost share requirement, 50% for topic 1 and 2. Topic 3, no cost share is required, but it's always encouraged. But no minimum cost share is required for topic 3 for red team. And then the periods of performance for topics 1 and 2 is going to be 24 months plus for technical, and then 3 months reporting. So total pop of 27 months. And then for the red team, they're going to get a little longer to be able to, you know, wrap up everything. So their technical period of performance is going to be 27 months. And then report out 3 months. So total period of performance for the red team is going to be 30 months. And that brings us to questions for Delta Qual 2.0. Yes, Allison. Oh, microphone.
Should have.
The German didn't grow up learning to play basketball.
Sorry, I couldn't capture. Okay, topic 1, please, question.
Go ahead.
The title says sorry, can you go back to topic 1? It says measurement-based installation qualification. But if you read the body of topic 1, it reads like qualification of OQ. So is it because you guys are demarcating kind of different way than us we are? To comment on that, please, thank you.
So, Mark and I have had this debate. Is maintenance and calibration of the machine IQ, or is it continuous of the PCDs? If it's not well maintained, if it's not doing what it's supposed to do, if you're not checking that on a regular basis and making sure that you're adjusting as needed to keep it within where you expect, I think you fail IQ, even if your machine has previously been done. That is why this is called IQ. But the intent is for this to be recurring maintenance, and what are you checking against? How are you checking when you need to go and make your measurements as part of either recurring maintenance or regular operational checks or what have you?
I have 2 questions. Oh, yeah, sure. Paul Wilson for Boeing. So first off, both topics 1 and 2 really seem to be very focused on methods development, if I follow it right, like methods to do enhanced qualification and method to do enhanced parameter development and parameter definition that defines a window. All that makes sense. It seems to me that you want to do that on a material system that's twofold. 1, that's very well known, which I think you acknowledge, but then 2, that you actually have a lot of data on. And then 3, this is not a data generation exercise. So we don't want to be breaking a lot of bars while we're doing this. So I guess what I'm kind of poking on a little bit is, why is 564 and aluminum silicon 10 disallowed when they are some of the most process sensitive alloys we deal with, that this method would be most useful upon.
If you want to make an argument for tie 6.4 in your proposal, we will read it. It will not get thrown out.
Thank you. If I could, I have one question on this topic. Really, I guess with topics 1 and 2, they're also very closely linked in a lot of spirit. So would there be any consideration to combine proposals that are trying to address topics 1 and 2 together? Option.
So you can definitely propose to both. That is entirely allowed. As far as one combined proposal, I'm being told it needs to be separate.
Yeah.
So I guess the answer to that is unfortunately no.
All right. Thank you very much.
Right. And if you're going to do that, make sure that topic 2 is not a prerequisite for topic 1 or vice versa.
As on part of NGC, previously worked in the last effort. Question about topic 2. You said it doesn't need to reference BD allowables as your baseline. Is there a minimum requirement? What can we get some clarification on what the reference? I guess it would still be.
This is not supposed to be an effort that is generating C&D basis allowables. I'm not going to say the requirement is an S basis, but something that can be compared against, that can be used as a reference, more preferably if you have data already existing in the material you choose to measure against. I don't know that I have a minimum set of coupons that I am looking for or a maximum don't exceed. Justify what you make sense, I think, is what it comes down to.
Yeah, so
He has a cube.
sorry. Yeah, so Matthew Krill, Bart's Global Advisors. Switching over to the red team topic briefly. So there's, a lot more mention of the U.S. government stakeholders in this, which I think is a good focus. Is there already a group of U.S. government stakeholders that you've identified, or is that expected to be part of the
No, we expect to ensure government participation from appropriate members of the JAMWIC.
Okay.
So
You already have.
yes.
Right.
Yash Parekh, EOS, topic 1, please, IQ. From the manufacturer standpoint, when we do IQ, it is essentially when you make a machine in Germany, you have a factory acceptance test. And then it gets shipped to US, for example, and you run a site acceptance test. Both these results are 200 line items on Excel sheet. It gets compared, contrast, and you fix it. And that's the IQ done. This tells me that now you are looking into a calibration procedure that has been done over so many years by manufacturer, and they vary manufacturer to manufacturer. So can you enlighten us about like what additional changes / how this approach is going to get benefited to manufacturers who are currently doing IQs?
Sure. So in some regards, like I said earlier, there's a terminology that I'm not using exactly IQ the way that you are using IQ. In my mind, and this is a philosophical argument more than anything, IQ is a recurring ongoing thing. If your machine falls out of maintenance, if it drifts too far, it fails IQ, even though the site acceptance test, those results are done, were done 2 years ago. I think in some regards, the measurements and the processes that we're talking about developing in this are measurements that would likely be done or added to a site acceptance test, or the factory acceptance test to ensure that the subsystems are working appropriately or what have you. There might be some, there might not be. This whole project is to figure some of that out. But I think a lot of this is more in some regards recurring maintenance that, if the machine OEM is contracted to do that maintenance, yes, they would have to do this testing or it would still have to be done. But it's, again, recurring, not necessarily and that's just a terminology that I'm using differently.
Any mention of anything about heat treat? Is it expected that we do everything and ask them to say it, or expected to do a heat treat of the variety of potential materials at the beginning?
So let me get you an answer on that one. At the end of the day, the material as we qualify it is in the as heat treated condition. So if you took this procedure, if you took a figured out a bracket qualification procedure, qualified it, you would do it in the heat treated condition. For this work, let me think on that one.
Second question I had was, it said that it was highly encouraged to use the fast, testing.
Mhm.
Does that then become a part of the cost share?
No.
Great. Okay.
Fast share is federal funded. Federal funding of that nature cannot be used as cost share.
So for, Alex Bridges with Henry. For topic B, or topic 2, sorry, are you looking for an actual part to be used as an example for the bracket qualification?
A part demonstration or feature-based qual demonstration, what have you, I think would be an acceptable demonstration. I don't know if we made it a hard requirement, but it demonstrate that it works for sure.
And then just wondered a question on, would it laser stitching be acceptable as well, or on?
For this, it's definitely not unacceptable.
This topic 2, kind of letting us define the requirements. What prevents me from saying my minimum strength is something absolutely ridiculous, like, I've got, I can't do taxes for, but I'm gonna do, and I want 30K aside as my minimum yield strength. Like, I know that that's ridiculous the way you put it, but are you sure you know what's the limits on that?
You need to. It does say characterized material. I would expect that does have some sort of material spec already that you are working against for that material. As part of the proposal, I do believe we require you to define why you believe the material is mature and appropriate for this. So it would have to have a material spec. I need to double check if I put a requirement in for a material spec already exists. Yes, there should be a reasonable acceptance criteria already to be leveraged. I'll leave it at that. I think this is going to be last question. I think we do need to move on for time's sake.
Maybe this will help with the last question, and maybe it'll help you decide what to do. With no call from Patel Memorial Institute, I run the Human Medias program. I suggest that you pick a material that has either a published spec with statistically based lot release numbers in it. All the SAE, AMS, AM specs have a T99 as the S basis.
Or if you want, we're currently following 9 different test programs, most of which are doing Cs and Ds, 2 of which are American makes projects, and several of which are not titanium or LC10 mag, including my friend here. But there's also the 7050 American makes program for Elementum. We've got one company that's doing 7030, AMS 7030. And there's also Inconel 625, which is AMS 7000. That's an S basis number, and we've got 100 data points for that. So if you want a statistical number to be matching against, talk to me and I can tell you which ones we've already got numbers for.
I may take you up on that.
Right, yeah, we're gonna move on, but if you have questions after this, email project call at americanmakes.us. In the RFP, it's on the website, it's everywhere. That's gonna come directly to me, kind of like the question, but I'm not gonna get an answer.
And for those online, just for your reference, we have to be out of this room by 4, so we want to make sure we. John Martin?
All right, so now we're gonna go over Gotham real quick. So this one has to do with or basically equivalent replacement for aluminum 7075. And this is gonna be from my memory, but I think it's equivalent also to the AMS 4141 spec, which is forged 7075, and there's calculated strength values in there. It's also gonna be a high focus on corrosion resistance, just because of the nature of the alloy and the applications that it's used for. So there's going to be 2 phases in this. Phase 0 is going to be more of like a pre-qual vetting phase, although it's going to involve a lot of data generation, coupon generation, and then that's supposed to set the stage and get acceptance to the government team to go on to phase 1, which is to build out MMPDS CD basis allowable data set. So I want to point out the technical document was a pre-qual document from AFRL, flight bulletins out. It's linked on the RFP page, ENFSB 25-01. This other one here, EZ's SB, is reference only. You could use that just for some insight, but this one here is required to follow. That basically gives you a test plan and other specifications in there. Heat treat needs to be completely finalized and investigated and optimized before doing the pre-qual. And then we also want people to look at powder reuse study, laser stitch zones, full build height operation. So this project call is required to use 3 different size LPBF platforms, small, medium, large. Those are specified in the RFP. The medium and large size are required to be multi-laser. And we also want some sort of equivalency consistency study across 3 different sizes within of the material properties that you're getting from the printers. I don't think there's really any standard way of doing that currently, but we do want that at least studied to understand the variability of the material coming off the printers. Like I said, you got to meet with there will be a government advisory team for this. They're going to have to give the blessing that everything's okay, accomplished in phase 0 to move on to phase 1. Phase 1 mainly consists of building out the MMPDS CD-based allowable set, data set. And that's pretty much the gist of it. There's some other notes in here, a lot of information in the RFP, a little bit of background of the 7075 legacy material, the significance of the corrosion resistance, and that's the main thing though, is the equivalent aluminum 7075 AMS 4141. Hopefully that's the right one. Breakdown for funding: 1 topic, 1 award. The award's going to be $5.5 million, and cost share is 50%. Period of performance is 20 months for technical, 3 months for reporting, 23 months total. So, a lot of money, not a lot of time. So you better have your ducks in a row, I guess is what that means. So questions?
I think a bunch of people who have 600 millimeter or less machines. I don't know where every next sheet is in the United States, so I asked everyone I knew.
I don't think there is a single NXG user that I, or 600mm machine user that I found that was interested in putting an aluminum alloy in the machine. There's one with CP1 in it in Long Beach, but like if you wanted to put scalp alloy or something which would fit this criteria, I haven't found a single one. Are you guys considering potentially reducing the requirement for needing that very large machine, especially given the cost to fill it?
Right. So thanks for the insight and a little bit of the research that you did. So we've heard that feedback already. So we will meet with the government SMEs that put this together with the team and get back to you with regards to modifying the classes of machines. The intent was to have a broad range of classes, and we attempted to bin them. But if there is an availability issue on that large size, then we'll certainly have to revisit to ensure that we're getting the appropriate response.
Okay. And the second question was, I mean, again, from the survey that I've done, it seems like an alloy from HRL and scalp alloy seem to be kind of like the two top contenders for something like this. But I mean, there were concerns brought up about scandium being needed to go to this and big scalp alloy. Are those types of considerations also being thought about? We talk about the alloy question.
Yes, so we're aware of those types of issues and they're tracked elsewhere within OSW. Particularly to scandium, we're not that we're not concerned about it, but we're not going to eliminate like a scalp alloy because of that concern. So I think that's well within scope.
Is one of the deliverables for this project going to be to send the data to Mattel to sponsor an MFBDS C&D basis entry?
So that is not currently one of the requirements within the RFP, but I would like to get with you to talk about our material allowable development programs in totality to talk about what that looks like.
Excellent.
Again, question concerning the corrosion resistance aspects. Is there a set or a particular set of service environments that you're considering in that corrosion resistance? Because as we know, it's very environmental driven. So what temperatures, what times, what environment, what media should we be considering when you're evaluating corrosion resistance?
So I don't have the RFP in front of me, but I believe we specified the test method that we're most interested in, but not the environments. There is a requirement to partner with the prime CEA or LSI, and we would expect them to spec out those.
And maybe to slightly clarify, is there a certain like rating, like, you know, there's like corrosion susceptibility ratings for technology. Are you looking for us to align to those?
I will have to, I don't think we specified, but I'll have to get back to you on that. And I think like wherever Cole is, if we can take that as a formal question, we'll respond.
Clarity, anything to clarify on that would be helpful.
Yep.
Second
part of the
So the
question.
second part, basically the corrosion susceptibility rating, like you'd have like an A, B, or C, I think.
Right.
ACB. I forget the ASTM spec, it's wrong, whatever, but basically, is there a certain rating you're looking for to be equivalent? Although I'm assuming you're looking at 775, and also 775 can be kind of a nasty actor, so do you accept those same risks or not?
Right. Understood.
So, James Woodman's machine wants to understand how mature you're looking for that alloy to be. Are you wanting something that's already been printed and got results, or are you after something new?
I will say that due to the dollar amount and the timeline associated with that, it would be wise not to look into something new and exotic.
Something that's ready. Second thing is I do have a large outbed machine, CP1, that I would build up material in, but also looking to get another machine. What are you allowed to include capital costs? Or, I mean, obviously there's a restriction that all the machines are tied up with customer product on it, but can we include cost towards a new machine in as well?
Yeah, I mean, it's 5.5 million, right? It's each of the machine. Generally, local,
Yeah.
Right. And I would be concerned about procurement timelines, to be frank.
lead time, right, is a topic, regards to acquiring a machine, right? Second topic, obviously, sizable investment, got to figure out if you can accomplish the rest of the scope, given the existing budget, obviously, cost shares model.
Yeah, we'll be in a very good position. Thank you.
Yeah, I would just say, if that is in your proposal, it needs to be highlighted in your plan.
I just want to give you something for the record on your corrosion ratings. NASA or commercial standard, what is it? 3029 is all stress corrosion cracking ratings. So it might be a good one to put in there.
Yep, tracking.
Okay, any final questions going once? Twice?
The window is open.
Yeah, question window for this is open until April 21st, so a week from today. If anything didn't get answered or asked, please submit those to Project Call at americamakes.us by next Tuesday. If you miss that deadline, train's out of the station. Okay, thank you all for attending and thank you for your questions.
Take it back.